Okay guys, this is week 4, so our 4th week, and this is our first lesson of the week. Our second lesson of the week obviously will be live. So I moved on. If you have a look here, here's our folder now, our first year science folder, and if we go up to the content library and into January 2020, I've actually moved this. So here's last week's stuff that I got you to do with the bottle. If anyone has a video of that, send it on to me. We've got 2 already. And I'm going to go into a new folder, so February 1st to 5th. Okay, so we're moving into February, our 4th week since the school closed. Okay, and we're starting something new. We're sticking with the whole let's get the theory done, and then we'll have the practical when we get back. So this is moving on to atomic structure. Something that is not easy, something that is, because if I do something like digestive system, well, you all have digestive systems. If I do something like cells, well, you can see them under the microscope. These are so small that you can't see them, so it's all based around theory. So it'll take a bit of time, and I'm sure you'll have lots of questions which we can answer over email, or we can wait and answer on in our second lesson. Okay, this is called atomic structure. It's basically the structure of the atom, and this here is an atom, right? So here you have some stuff in the middle there, so some stuff contained in this yolk in the middle. We'll get to what that is in a minute. And then there's other things that, so these are not lines, these are little small particles that fly around and around and around. They keep going around and around and around. Some of them are going around that direction, some of them are going around in this direction, and some of them are going around in this direction. They're going round and round and round and round. And that's an atom in a nutshell. So we're going to look at what are the different things that are in the middle and what are the things that are flying around the outside as we go through the atomic structure. This is just what you need to know. So when it comes to Junior Cert, here's what they want us to know by the end of this week. So by the end of this learning outcome. So things like what's the definition of an atom? What's these 2 numbers, the mass number and the atomic number? We'll be getting to those. We have to be able to draw the first 20. So we'll be doing that now on Thursday. We'll be drawing them on Thursday. We have to look at these subatomic particles. So particles that are even smaller than atoms. So particles that are inside the atom itself. And what is it? Characteristics means like your characteristics might be brown hair, blue eyes, that kind of thing. So characteristics, so stuff we need to know about them. We have to look at the subatomic particles, which are protons, neutrons, and electrons. You've probably heard those words before. And figure out how many protons, neutrons, and electrons are in the different atoms. And then look at these 2 guys, Dalton and Niels Bohr. And we'll have a look at what contribution they made to the atom. So that's what we're going to be doing over the next 2 classes. All right. So we'll go through it. Right. Definition first off. Really important to know this definition. An atom. So an atom itself is the smallest particle of an element. So it is an element that has the properties of that element. So see, what's an element first off? Well, I'm going to spin down to the bottom for a second, right? I'm just going to show you. And you've seen this loads of times, this thing. Because there's a big, huge one sticking on the wall in the lab, and there's you have one in your homework journals, the periodic table of the elements. So this is where the atoms come from. And you think, what elements have we got? Do we recognise any of these? Because we haven't really looked at this before yet. Well, you might recognise iodine, the red stuff that you put on the potato and the pasta. You might have heard the word chlorine before in a swimming pool or in water. Oxygen, most of you would use quite regularly. Helium in a balloon, you might recognise. Things like silver, you might have heard of before. What else would you know? You'd know lead from roof of houses. You might know arsenic, a rat poison. You might have heard of gold, AU. So there's loads of different elements there, a lot of which you've heard of, a lot of which you haven't. And what we're going to have to do, so if you look at the numbers, here's number 1 up here in the corner, and then it goes to number 2, then it goes 3, 4, 5, 6, and so on, all the way up as far as number 20. And they're the ones we're interested in Junior Cert. And number 20 is them bones need calcium. So that's where the elements come from. That relates to the definition of the atom that we were looking at there a second ago. Let's go back to that definition. quickly. So the smallest particle of an element that still has the properties of that element, and you see to learn a definition. Where all this came from. The Greeks originally, so before we had atoms, the Greeks thought, well, everything in the world, everything in the universe is made of earth, wind, water, and fire. That's what they thought. That's what everything was made up of. But then Dalton came along and said, well, maybe it isn't earth, wind, water, and fire. Maybe everything. So we're talking all matter. Remember matter? All last week's work, solids, liquids, and gases. Everything, a solid, liquid, gas, everything that exists is made up of tiny particles called atoms. So Dalton came up with the word atom, and everything wasn't earth, wind, water, and fire. It was in fact atoms. So inside the atom, then, you have 3 subatomic particles. So you have 3 subatomic particles that make up an atom. So you say, well, an atom is made up of 3 things. It's made up of electrons, protons, and neutrons. And again, you've probably heard those words before, I'd say. Electrons, protons, and neutrons. Okay, so here's what the atom looks like. So here's one of the atoms. It's number 7. So nitrogen. So this is this over here is an atom of nitrogen, N for nitrogen. And if we look at the text first, the protons and neutrons are located in the center of the atom. So in the center here, we have the protons and we have the neutrons. And those protons and neutrons are nice and safe here in the center. And the structure that they're held inside is called, same as we had in cell, when we do the cells back in September, nucleus, inside the nucleus. So the protons and neutrons are in the center of the atom in a structure called the nucleus. And the electrons are out here. So we have, look, here's the electrons. The electrons are the things that are whizzing around the outside. So here's an electron, that's flying around. All these electrons are out here. And there's 7 electrons that are whizzing around the nucleus, where the protons and neutrons are inside. So the electrons are in an electron cloud or in rings or in orbits. This picture is obviously drawn in 2D, 2-dimensional, on a page. But really, what it should look like is what we saw at the very top. It should look like this here in 3D, but it's just much more difficult to draw. When we're drawing it on a page, we draw it like this in 2D, 2 dimensions. Okay, so each of the subatomic particles, so each of the protons, neutrons, and electrons have 2 things. They have a charge, same way, your battery has a positive up the top and a negative down the bottom. So they have a charge, so they're either positive, negative, or neutral. And they weigh something. They have a mass. Now, obviously, we're not going to be able to pull out the weighing scales and start weighing protons because they're so small. So protons, neutrons, electrons are so small, so tiny, that microscopes are not going to even come close to seeing that they're that tiny. So we can't see them. So usually if I got you to weigh a potato, you'd say, oh, well, maybe it's 20 grams. If I got you to weigh your school bag, you might say, oh, it's 1.2 kilograms. If I got you to weigh, I don't know, something really heavy, you might say it's 3 tons. A car, say 3 tons. But these are so small that we can't use grams or kilograms or tons. We can't even use milligrams, something we'd say quite small. We have to come up with a different unit. Mass units, atomic mass units, AMUs. So if I was to say to you, weigh a proton, you're not going to give me the answer in grams or kilograms or tons. You're going to give me the answer in atomic mass units. So remember that for a second. AMU means atomic mass unit, and it's a measure of mass. And here's the 3 subatomic particles. So again, we have the proton, the neutron, and the electron. And we saw it on the diagram that the proton is in the nucleus, and the neutron is in the nucleus, and the electrons are whizzing around the outside in these electron clouds. The mass we just spoke about there. So if we wonder what's the mass of a proton, it's 1 AMU, atomic mass unit. The neutron is also 1 AMU, atomic mass unit. The electron is nowhere near that. The electron is much, much lighter. Is 1 over 1,840 units. So what would that mean if I was to get a seesaw like this? I wanted to balance my seesaw in a line like that. So here's the wedge in the middle, and here's a seat on that side, and here's a seat on that side. And I want to balance 1 proton on one side And on the other side, I wanted to balance it using electrons. Well, that would mean this 1 over 1,840, that if I was to put one proton on this side, I would need 1,840 electrons on the other side to balance it. So it would take 1,840 electrons to equal the mass of one proton. The last thing, same as you have in a battery, a proton has a positive charge. Neutron is neutral, so they've no charge. And an electron has a negative charge. And you're going to see a connection between protons and electrons in a minute, because if an element has 100 protons, it's going to have 100 electrons, because if you have 100 positive charges, so loads, if you even less, say you have 5 positives, you're going to need 5 negatives. So they're going to balance it. Charges have to balance out. Okay. So these two definitions, again, these have to be learned. If you're looking for the atomic number, is the number of protons. The mass number is the number of protons plus the number of neutrons in the nucleus. Okay, all this, I'm going to put all this together in the one thing for you in a moment. Okay, so here's an atom of nitrogen on the right hand side there. Now if I look at that, so all of these, if you take any square out of that big periodic table, you get all this information. So up here I have a number, down here I have a number, here I have the name of the element, and here I have the symbol. So I can get a lot of information from that. Okay, so as we said, this here is your symbol, this here is the element name. Okay, and then the two numbers I'm interested in, this one here is your atomic number, and this one here is your mass number. So if you think what that tells us then, if I say, well, okay, well, the atomic number of this one is going to be 7, that means it's going to have 7 protons and 7 electrons. So that small number tells me how many protons and how many electrons it has. It's a bit of a calculation to figure out the mass number, because remember, the mass number is protons plus neutrons. So I'll show you how to work out how many neutrons there are in a second. I'll leave that as a question mark for a moment. Okay. This guy, Niels Bohr, so this is where the second person comes in. So Niels Bohr stated that electrons move around the nucleus in orbits or shells or clouds. So the electrons move around the nucleus. The number of protons equals to the number of electrons. So so if the atomic number here, as we said, is 7, that means it's going to have 7 protons, because that's what the atomic number means, the amount of protons. But if it has 7 protons, it also has 7 electrons. That's what that means there. Okay, there's a definition again of the two. So this one here, the mass number, the number of protons and neutrons. So the last part of this in an atom. So if the mass number of nitrogen, as we said, is 14, we can work out the number of neutrons. Because that number gives us the amount of protons plus neutrons, we can do a little sum to work out the number of neutrons. We can say, right, well, if there's 14 protons plus neutrons, and we know there's 7 protons, we just take that away, and that will tell us that there are also 7 neutrons in the element. So we're going to do a couple of those in a moment, okay? So if I go to this periodic table, I'm going to take any random one. I'm going to take, let me see, we'll take sodium, right? So I'm going to take this element here, right? Sodium is 1121. I'm going to draw it out separately, right? So if I draw Na, which is sodium underneath, and it has 11 up here and 21 down here. And this is, I'm just pulling that straight out of the periodic table. And I'm wondering, okay, well, how many protons, how many neutrons, and how many electrons has sodium got? That's what I'm interested in. Many protons, how many neutrons, how many electrons, And if we know that, then that'll lead us in nicely into our second lesson of the week of actually drawing these things, of what they actually look like as atoms. So when I look at the information I have here, right, I have a piece of information there, I have the symbol, I have the name, and I have this piece of information there. And I'm going to just say, well, okay, this one here is our mass number. And remember, that is protons plus neutrons. And this one here is our atomic number. So we can, if I go back to it and say, what does the atomic number tell me again? What does this 11 tell me? Go back to that last bit there. The atomic number tells us the number of protons. And it also, that means that it's the same amount of electrons. So I go back down and I say, okay, well, that number tells me great amount of stuff. Because I can tell from that 111 that sodium has 11 protons and 11 electrons. The only thing it doesn't tell me is the number, The only thing it doesn't tell me is the number of neutrons. Sorry, just clicked out of it there for a second. The only thing it doesn't tell me is the number of neutrons. So what I can do is, to work out the number of neutrons, sorry about that, I can take the mass number away from the atomic number, or the atomic number away from the mass number. So the neutrons is the little sum we have to do. So I say, okay, well, the amount of protons and neutrons is 21. Take away the atomic number, 21 minus 11, which is going to give us 10. Okay. So we're going to have 10 neutrons. I think that number there should actually be 1123 and not 21, which means that should be 23 minus 11, and that should be 12, not 10, not 11. Okay, so the only thing you have to remember is that the small number here tells you the protons, tells you the electrons. To work out the neutrons, you take the small number, the 11, away from the big number, 23, and that gives us the 3. Okay, and you can do that for any element here. Any element in this periodic table, you want to work out the protons, neutrons, and electrons. The small number tells you the amount of protons and electrons. So manganese has 25 protons, 25 electrons. Iron has 26 protons, 26 electrons. Cobalt has 27 protons, 27 electrons. Only thing you have to work out then is you take the small number with the big number to find the number of neutrons. So atomic number away from mass number. And here's it is done out for you in text. So for potassium there, potassium has 19 protons and 39 protons and neutrons. So from, if I want to find the number of protons, it's just going to be the atomic number, it's going to be 19. If I want to find the number of electrons, that's the same, it's going to be 19. If I want to find the number of neutrons, then I take 39 minus 19, which is equal to 20. And then this sets us up, if you can do these, this sets us up to be able to actually draw these out then later on in the week. So tricky stuff. Take your time. You might have to look at this a couple of times to kind of get a feel for it, but you can ask any questions that you have. 2 things I want you to do for homework. A bit tricky. It's going to take you a bit of time, this one. The questions, nice and short. The questions take you about 5-6 minutes. Won't take any time at all. You get that done during the lesson today. But what I want you to work with later on for the rest of the week is a bit more time consuming, but you have until the end of the week to do it. Okay, so number 1 is to answer the questions. So number 1 is just those 7 questions, and make sure they go into the homework section. And when you label the homework section as homework for February, so it's clear that you've uploaded some new homework, so I can go in and have a check and see where people are having difficulty. So it's important that I can check it before the next lesson. Okay, the second thing I want you to do, using materials from your house. You don't got to go buying stuff. I guarantee I've seen this made from all sorts of things, random bits of stuff from your house. I've seen it made from jelly beans and string. I've seen it made from spaghetti. I've seen it made from Play-Doh. I've seen it made from shoelaces. I've seen it made from loads of different stuff. What I want you to do is make a model of an atom, any atom. This model should show the nucleus, So you should be able to see a nucleus with the protons and neutrons. And then outside, somehow, the rings containing electrons. Post the pictures of your model to the notes section of your homework. And what you want to have in this, you want as much as possible labeled. So I should be able to look at your model and say, this person has the protons and neutrons in the center. If you can fit the positive charges and the negative charges on the protons and the electrons, if you can fit the mass, even better. And so here's an example of one that was drawn. So this person, and it's important, I'm looking at this, I'm wondering, what is this person? This person has spotted that here's the electrons out here, and they have a negative charge on them. All the blue ones are electrons, negatively charged. And in the center, they have the protons and neutrons, and most importantly, that the right amount of protons. So if there was 6 protons, there was 6 electrons. If there was 6, and then they worked out that this is an element of carbon, so they worked out that there was also 6 neutrons as well in carbon before they made it. This is done with chopsticks and those foam balls painted, but you can do it with all sorts of things. Is all I want is a model of an atom, and if you take a picture of that and upload it. So 2 things by the end of the week: your 7 questions and pictures of your model that you've made. And it can be done quite quickly, or it can be quite elaborate drawings. The last thing is you keep an eye on your first year Schoology group. I am hosting the fun day on Friday at 1:30. Should be a bit of crack. It's a cook along. So if you keep an eye on that Schoology page for ingredient lists and recipe lists, and join in Friday afternoon, and I got planned bolognese and garlic bread and stuff like that. So a bit of crack on Friday. But on a science point of view, send me an email if there's anything coming up that's causing you any bother. And if not, I will talk to you in the live lesson later